This is the last part of section 9.3. I'm going to do a mixing problem with you. And let's just read through it. We've got two tanks. Each has 100 gallons of stuff in it. Tank A has water and 150 pounds of salt. No. Tank A has pure water. Tank B has water with 150 pounds of salt. And then fluid starts to flow out of A into B and then out of B and into A. So the volume of each tank remains constant because you've got two going out and two going in. Now, let's let X be the amount of salt in tank A and Y be the amount of salt in tank B. We want to set up a system for dx dt and dy dt, and then solve it to find out how much salt is in each tank at any given time. Now, what we expect to happen is over time, all the salt over here in tank B, it's going to dissipate and we'll have an equal amount of salt in each tank. So in the end, if we start with 150 in B and 0 in A, we should end up with 75 pounds of salt in each tank. Let's see if that really happens. So for tank A, so dx dt, the rate of change of salt in tank A, it's going to be rate in minus rate out. So R in minus R out. The rate in is the stuff coming from B. So the concentration of salt in tank B is Y, that's the amount of salt in tank B, over 100, and then times 2 gallons per minute. So concentration times the rate it's going in. And then we subtract, and don't worry about the fact there's 150 pounds of salt in tank B. That's not going to come into play until we state the initial conditions. Minus rate out. Rate out is the stuff leaving tank A. That's got concentration X over 100, and it's leaving at 2 gallons per minute. So that's dx dt, I'm going to clean it up over here, is negative 1 over 50x plus 1 over 50y. I want to put the x's first and then the y's because I'm going to make a matrix eventually. For dy dt, again, rate in minus rate out. Well, the stuff coming in is coming from A. The concentration in A is X over 100, multiplied by 2 because it's coming in at 2 gallons per minute. And then what leaves is Y over 100 times 2. So if I clean that up, I get dy dt is positive 1 over 50x minus 1 over 50y. There's my system. In matrix form, I have it here. And in the initial conditions, that's where we record how much salt is initially in either tank. So tank A has 0 pounds initially, and tank B has 150 pounds initially. So let's now solve that system. First, we're going to find the eigenvalues. So we want to solve 0 equals the determinant of A minus Ri. So negative 1 over 50 minus R, 1 over 50, 1 over 50, negative 1 over 50 minus R. All right, I'm going to multiply that out, R squared, and then I'm going to get positive R over 50, and then I'll get another positive R over 50. So 2 over 50 is 1 over 25 R. And then I'll get a positive 1 over 50 squared, but then I'll subtract 1 over 50 squared. So this is it right there. That's all I'm getting. Let's factor that. R times R plus 1 over 25. So I've got two eigenvalues, 0 and negative 1 over 25. For each eigenvalue, I want to find an eigenvector. So again, state which eigenvalue you're using so I can follow your work. Let's do the -1 first. And in this case, we want to solve A. Remember, it's A minus Ri. So since R is negative, this would be A plus 1 over 25I times big K equals 0. Okay, A is up here, so I want to add 1 over 25 on the main diagonal. And let me think, -1 over 50 plus 1 over 25. 1 over 25 is 2 over 50. So that'll give me positive 1 over 50, and then 1 over 50, 1 over 50, 1 over 50. You can pause it and think about that if you want, but that's correct. K1, K2 is 0, 0. So that gives me two equations. 1 over 50 K1 plus 1 over 50 K2 is 0. And then the exact same equation, which of course I can ignore because it's just the same equation. Solve for K1 in terms of K2, and that gives me K1 is negative K2. I'll let K2 equal 1. So big K, and I'm going to call it big K1, has a 1 on the bottom, and then K1 is negative K2, K2 is 1, so -1. And that corresponds to R equal -1 over 25. All right, now let's do the exact same thing for R equals 0. Now I want to solve A minus 0 times I times K equals 0. So AK equals 0. So A was -1 over 50, 1 over 50, then 1 over 50, -1 over 50, K1, K2. These are always really simple to solve, these systems. So this gives me -1 over 50 K1 plus 1 over 50 K2 is 0. And then the next equation is just the negative of the first equation. And since it's a multiple of the first equation, I'm going to ignore it. So solve for K1 in terms of K2, and I get K1 equals, move the K2 over, multiply by 50, K2. So let's let K2 equal 1, and I get big K2 is 1, 1. And that corresponds to R equals 0. All right, now we're going to write down the general solution. Big X, which is little x, little y, is C1, K1, which is -1, 1, e to the R1, which is -1 over 25, t, plus C2, K2, e to the 0t. E to the 0t is 1, so I'm going to leave that off. So there's our general solution. And now we're going to solve the IVP given by x of 0, y of 0. Remember, we had 0 pounds in tank A and 150 in tank B. So on the left, I'm going to get 0, 150. And on the right, I'm going to get C1, -1, 1, e to the 0, plus C2, 1, 1. So that gives me two equations. 0 equals -C1 plus C2, and 150 equals C1 plus C2. So if I add those two together, I get 150 is 2C2. So C2 is 75. and plug that into the first equation to get C1 is 75. And so my solution looks like xy equals, all right, C1 is 75. So I'm just going to put that right into, I'm going to distribute the C1 and the C2. So C1, so I'll get negative 75, 75 plus, oh, e to the what? Where am I? Oh, I'm up here. E to the negative 1 over 25t. You could also leave the 75 out. Don't worry, you could leave it out here. I'm going to put it in though. Plus 75, 75. Now, that's actually two equations. That's little x equals negative 75 e to the negative 1 over 25t plus 75, and little y equals positive 75 e to the negative 1 over 25t plus 75. If you graph those, that parametric curve, you get this red solution. But I graphed a whole bunch of solutions for different starting values, for different initial conditions, like maybe not 150, maybe they each had equal amounts of salt in them. But all solutions tend toward equilibrium. The amount of salt in A should be equal to the amount of salt in B, because the tanks are intermingling, and so eventually they just even out. All right, so that, I went really fast, but you can slow my voice down with YouTube. So here's one for you to try. It's got some fractions in it. I'm giving you like the answers. I'm saying, okay, set it up and show that that's your setup, and then solve it and show that that's your solution. So you should do that. You can do it on at home, because I have the solution on the next page, but I strongly suggest you don't read the solution until you try it for yourself. And that concludes section 9.5.